Today I'll solve two problems about electric circuits. First, I want to explain some basic ideas. Electric currents means movement of charges. Yes. In circuits, charges move because of a source. There's two types of source. DC, it's a direct current, and the AC, alternating current. Yes. In both of my problems, I will solve in the AC source. DC, that means current moves in one direction, like a battery. AC, its current changes direction many times per second. In these problems, we use AC source. DC, we have solved this in DC source in the previous video. So I want to show you how it actually acts. Like this, our DC source. Yeah, we can see that current moves only in one direction. It moves like a battery. So it's our the AC source, alternating current. Here, current, if I increase the speed of current, we easily can see that current goes forward and the backward, charges move left and the right. Yes. Okay. If we understand the basic understanding, you have a basic understanding, let's solve the problems. And for solving problems, I will use the Prada method. Prada method. Okay. First of all, I want to explain what these letters stand for. Prada, PR, that stands for pattern recognition. Our A, it's abstraction. D, it's decomposition. And the last one, A, is the algorithm design. Yes. First of all, decomposition means break problem into parts. I want to start with decomposition because to solve this problem, I need to break this some small parts. We need to understand how is it working. Actually, yes, this we have an alternating source is 20 volt. So we have a plate and there is resistor and the current goes. Yes. Okay, we need to find the spacing between capacitor plates. So actually this distance. Yes, it's known resistor, current, and voltage. Yes, in the DC current, its voltage and the current is not changing; it's constant. But in alternative current, it's changes per second. So our formulas and the meaning of the voltage and the current is not the similar on the direct current in like DC. So we have resistor, the composition part, we have resistor, we have capacitor, and this is known as its AC circuits. Also we have a diameter electrodes, that means we can easily find the area. Also we have a frequency. So to find the distance between the capacitor plates, we need to write the formulas that we need to use. Yes? Yeah. First of all, what is a capacitor? Yes, we need to find we need to understand what does it mean, because before the writing just formulas, we need to understand. Yeah, capacitor is two plates. Any two plates, charges collects on plates and create electric field. So we need distance between plates. Yes. Also, in faster simulation, you can easily see these two plates. Okay, uh, let's move to the next part of our method, that is abstraction. Yeah, abstraction means it's just use simple formulas. Yeah, there is voltage here. As I mentioned, there is another formula of voltage and current, and because it's changed over time, it will be like um, voltage zero cosine omega time. But in the problem, we have voltage zero, maximum voltage, and no need to use this formula. I'll just write it. Also, we have a current. Current is show how fast charges move. Also, resistance. How hard for current? How hard? Yeah. Also, capacitor. Capacitance. How much charges it can store. I can write it just like a storage. Yeah, there is a very important idea in AC circuits. Capacitor likes like a resistance. We call it resistance of capacitor. There is a formula of resistance of capacitor where this x is resistor of capacitor. This omega is how fast current changes. So next move to our the next part of our method, that algorithm design. Yeah, we understand now. We understand what is a capacitance, the graph, also what we have and what we need to find. Yes. Okay, let's move to the formulas. Not just writing formulas, also using this algorithm design. Yeah, first of all, now step by step we need to solve it and find how fast our AC changes, find total resistance, total resistance. Also find capacitance. Find capacitance. After that, we easily can find our Z. Yes. Okay. First of all, we have this kind of formula. I0, voltage 0, it's the maximum, and the R maximum, yes? Maximum resistance. But we have not only the resistance, uh, we also have this XS. That stands for capacitor resistance, yes? So our R max will be R squared plus XS squared over the root. Yeah. Also, we can open this formula. It will be like this. Yeah, I think there is no need to explain these things because it's just a math. Okay. This we can easily find our capacitance. I will write it very quickly. Yes, our current will be I will use this root because of um, because we don't need this quadratics. So our capacitance will be I0 over omega Vc square minus I0 R squared. So yeah, we find total resistance formulas. We find formula of DC or capacitance, and we can easily find our distance. Okay, the last formula is formula of capacitance. Yes, capacitance is A0 A over T. Okay, we don't need this kind, yeah, because we don't have a dielectric. So I'll write like C 0a over C. As you remember, we have a D diameter. We can easily find our area. So the final formula will look like this. I0. Okay. I will just put the numbers. Is a constant number, E is 0. Okay, P is 3.20. Our D is equal to 15 centimeters. 15 in quadrat is 225. Our omega is 2p frequency. 2p is 6.28. Also, our frequency is given. It's 36 kilohertz. Also, we have a voltage 20 volts. In quadrat, it will be 144. I0, we have also I0 is 0.65 milli. In quadrat, also we have a resistor 20 kilo. Yeah. Also current to 0.65 milli. Yes. After a little bit difficult calculating, we have 0.5 10 power minus 3. It's actually 0.5 millimeter. So we'll find our distance between capacitors. So we have solved this problem, but it's not actually the end of this problem, because we need to understand the what is our main idea, our pattern recognition. We have also done abstraction, decomposition, algorithm design. But what is the pattern recognition in this problem? Okay, let's understand it. Okay, for understanding, I will use Hallstatt, of course. Yeah, we can see there is. Okay, I will increase the speed of current. Yeah. Okay. There is the pattern recognition. What is it mean? Pattern recognition means we need to see the behavior. See behavior. Yeah. There is the very important pattern. When frequency is higher, our current is bigger. Capacitor allows more movements. Frequency is higher, current is bigger. Also, our capacitor allows more movements. Okay, let's see in the Hallstatt simulation. I will increase our frequency like maybe 100 or 200 kilo. Foresee the differences. Yes, you can see there. Yeah, I increase frequency. I see charges move very fast. This is our the second problem. We have a resistor and a capacitor of unknown values. First, we charge the capacitor and discharge it through the resistor. By monitoring the capacitor voltage is oscilloscope, we see that the voltage decays to half its initial value in 2.5 milliseconds. We then use the resistor and capacitor to make the low pass filter. What is the crossover frequency? We need to find the frequency. Also, I will use the Prada method. Yeah. There is no need explanation of each of them. Let's move to the problem. Let's solve it using this method. Okay, first of all, as you know, we use decomposition. Yes, decomposition. Uh, what does it mean? It means breaks into parts. Uh, yeah, we have capacitor, resistor, voltage decreases with time. Yeah, we need to find crossover frequency. Yeah. So the composition help us to understand what do you have and what do you need to find. Yes, steps. The first step is find time constant. Second step, use exponential decay. Third is find frequency. Okay, uh, let's move to the next method. It's abstraction. Abstraction. Yes. Abstraction means, what does it mean? It means using formulas. Yes. So we have the formula voltage decay. We have this kind of formula. So I've explained this formula in my first video. But okay, it means that the voltage is decreases over time. It's time dependencies. Yeah, it's in the uh, in the problem. It says that decays to half its initial value. Yes, that it means that it half voltage. So V over V0 is 1 over 2, yeah? 1 over 2 equal to exponential time over RC. So this we can find our time constant. So RC equal to, we need to write ln for drop it as exponential. So it will be like this, ln 2. So frequency it's equal to 1 over 2 p RC. Yeah. So you can use the algorithm design to find our RC. After finding our RC, you can find our frequency. Yes. This first formula, this second formula. Okay, algorithm design. Algorithm design. Yeah, algorithm design means step by step solution. Yeah. Okay. First step is find. We need to find use half decay. RC. RC equals 2. We also have the time. It's 2 half life 2.5 millisecond. 2.5 millisecond over ln2. It's equal to approximately 3.6 millisecond. Okay, after that we easily can find our frequency. 1 over 2p RCS. It's approximately 44 Hz. So we find our frequency, but it's not the end of our problem, because we need to understand what actually is happening. Yes, for understanding, I can show you this in uh, faster simulation. So there is a switch because after in the first we need to um, charge our capacitor because charge is stores the charges. Capacitor is store charges. After storing charges, we can switching it to the resistor. So when it's switching to resistor, it's not connecting to our the store. Yes. So when I switching this, our source it will be the capacitor, but uh, capacitor it's not the very it's stores charges, but it's not the um, infinite. After the after time it will be the decreases. It will and the more and the more and less charges. So yeah, I will start it. Yeah, first of all, to see easily, I will increase our current and increase the uh, speed of simulation. Yeah, there is you can see voltage and the current values. Yeah. Okay, this capacitor it stores some charges. I will switch this. Yeah, and in this we can see the current. Yeah, you can see it's 200, 100. Our voltage is decreasing by time. Our current is also increasing by time because it was a micro and no, it is nano ampere. Yeah, our current and the voltage is increasing over time because of the what? Because of the frequency, of course. Yeah, it's a maximum speed of current and the maximum speed of simulation. Yeah, after time, after some time, there is no current actually. Yeah. Okay. I hope that you understand this behavior. So there is also pattern recognition. Yeah. Also connection with the previous problems. So um, from problem one, we remember that higher voltage, more charge. Yes, capacitor it stores energy. So in this problem, our voltage decreases with time, charge also decreases. There is the same idea. There is first problem, there is second problem. Voltage decreases with time and our current also decreases because look, the voltage it increases. It means move another move more charge, yes, but we uh, we know that our charge also depends on our current. More charge it means more current, bigger current. There is a dependencies current and the voltage. Yeah, we can easily say that capacitor controls how charge changes. Yeah, in simulation we see that voltage on capacitor decreases, charges move slower and smaller over time, yes. So this is called exponential decay. exponential decay. So it's the same behavior of capacitor as in the first problem. So now I conclude that capacitor it stores energy. Voltage and current depend on circuit condition. Also, in AC source depends in AC source depends on frequency. Yeah. Uh, Also in Falstadt, yeah, in Falstadt, we can see how charges move, how current changes, how capacitor charges and discharges. This makes the physics clear in the visual. So thank you for your attention. Thank you. Goodbye.